fast that time. Started getting those straw-colored chips. That should give me a little bit to spare so I can make a finish cut. Although that finish there is quite a bit better. Just reducing the depth of cut helps a lot. 26 thousandths left to go. Oh yeah. Looks like I got 14 thousandths to go. Rather than take a 7 thousandths cut, I think I want to sneak up on it. I'll take a 5 thousandths cut, and then I'll just do a very light finish cut and decrease the downward feed rate to just clean up that finish a little bit. You can tell by the sound. It's like it's cutting and not cutting, cutting. So there's almost like there's a waviness to the wall. You know, I don't know whether or not that's variations in hardness of that material, or whether or not something's going on here that I'm not aware of. Which, hey, that could definitely be the case. It's entirely possible there's a lot going on that I'm not aware of, especially in this house. All right, so I guess if I wanted to get a little more serious about measuring this bore, I should get a different measuring tool, huh? $64 to $72, 8 thousandths. I'm going to take a 5 thousandths cut, which should give me 2 thousandths of clearance if I can hold the accuracy. And I'm going to, like I said, I'm going to change this feed. Let's slow the speed down. I'm going to probably increase the speed a little bit. All right, wish me luck. Just for the heck of it, I'm going to do something I didn't try before, which is I'm going to reverse the feed. So I'm going to actually feed from the bottom up instead of just letting it come back from the spring on the quill and having it rub like I've been doing. So let me just bring this around. So what I was talking about was I was wondering whether or not it would be more advantageous to start from the bottom of the hole and feed up. No, I guess that doesn't make sense, because then you're catching this back edge of the brazed on tip here. So no, that doesn't make sense at all. Nope, not quite there. All right, so I would have failed if I was going for a precision fit there. Overshot it. I got a little tired of waiting, got a little careless, and I mean it's not unusable, but you can see it. See that? How much that rocks? I could have done better. Everything about my setup seems pretty rigid. That's back and forth play there. It's not side to side play on my spindle. So I still don't quite understand why this cut was like almost intermittent. And if I feel the side there, I can actually feel I can feel like a ridge or something going on there, which I don't get. So I have an idea of how I'm going to locate, of an easy way for me to locate the exact position of these holes on the plate, or the slots, I should say, the two ends of each slot. And basically, in order to do it, it involves me taking this shaft assembly out of here, and you know, this bearing feels pretty skunked. It's not turning anywhere near as smoothly as it should. And these bearings are going to be cheap anyway, so it seems silly not to replace them as long as I'm going through all this trouble. So I'm going to take this assembly out of here, hopefully without destroying it. It's got a lot of rustification on it, and not quite sure. There are some clues here as to how this goes together. There is a snap ring on the end of this shaft, which would tend to indicate to me that by design this shaft should go out in that direction. There is a hole for a set screw right here, which I think actually the set screw already fell out. I think I remembered finding a set screw. When I was tipping this over, something fell out and it was a set screw. So I'll double check to make sure there isn't anything down there, but I think that's already removed. So the set screw is what keeps this from being able to move this way back and forth on the shaft, more than likely. So I think if we take that snap ring off and the set screw is removed, should be able to drive this whole shaft out in this direction, and maybe that bearing will come with it. Not sure yet. The bearing on this side looks like it's pressed in. Alright, so I put it in my shop press, and this bearing pushed out this way with the shaft, and then this bearing popped out on this side. So that's interesting to me. But I think that the diameter behind this bearing is slightly bigger than the diameter in front of this bearing. So this bearing, I think, sits on a shoulder here. So I'm going to have to I'll just keep pushing it in that direction, and hopefully it'll all come out that way. Because right now I don't have enough clearance to get this out. It's kind of tricky to get it set up on the shop press over there. I'm wondering, now that I broke it free with that initial bang, maybe I can just tap it out with a drift pin on the bench. That would be a little bit easier. Spoke too soon. Okay, so it comes out to a point and then stops because the bearing isn't going to fit through there. So now we've got to press the shaft out of the bearing that's on this side. So I'm finally about to get this bearing off, but before I did, I wanted to show you my setup. I finally smartened up and put it in the vise, so I got one less thing I need to hold on to. I found a couple of pieces of stock that were close enough inside that when I shimmed one, they basically are keeping the outer part of the bearing supported so the shaft can travel downwards and bashing on it. I finally got it to go. I tried heating it with the torch. That was a no-go. I put the puller on it. The puller jammed up on me because it's completely destroyed. But the good news is this is finally moving, and I'm going to have this out in a moment. There it is. Alright. So there's the bearing. Completely destroyed the bearing, but of course it was not that great anyways. Actually, one of the two was okay, but I mean, why change just one when you're gonna, you're gonna go through the trouble of doing that. So now, before I try and pull this back down, push this back down, there's a snap ring down there that's gonna keep this from traveling out that way. I'm just tapping this up closer so I can get to the snap ring more readily. Snap ring pliers are. I think I'd learned my lesson. Alright, so as a note to myself, well actually, pretty easy to see. The side that has more sawdust and gunk in it is the side that's up against where the disc sander. There's the shaft. So all that's left to do is get this bearing that's jammed on the shaft off of here. Alright, I got the bearings out. They're part number on them, they're NSKs. They're 6202Zs. So they're pretty common bearings. They should be cheap. Alright, so let me show you the setup, but before I do that, let me just explain real quick. The card filled up on the memory card filled up on the camera. So what all that I was doing here with the dividers, I actually I was having trouble finding the marks, my marks that I had made with the punch, the transfer punch, and so what I did was I just took these dividers, these rusty old dividers, and I set them by eyeball by putting this locating pin in the middle of the casting there. I eyeballed the center point of this to the center point of one of the holes that I just had the transfer punch through, and then by taking that, putting the locating pin in here and holding it like that, I was able to sweep around while looking with the magnifying glass and locate my 2 points. and then I just circled them with a Sharpie so I could find them easier. And then what I did was I figured out which way the slots would have to run, and I made a couple of arrows with the Sharpie so I know that I'm going to start my slot at these points, and I'm gonna mill a slot this direction on this one. I'm going to mill a slot this direction on this one. Now I don't have to locate the other end of the slot, because by having it on the rotary table, all I have to do is know what position I'm starting at, and go 90 degrees, because I want this thing to be able to switch from horizontal to vertical, and that's just a 90-degree movement. So I actually even kind of verified that by taking my square. If I imagine a line running from my existing transfer point to transfer punch hole over to the center line, or the center of my guide pin, and then I have a line 90 degrees up from that, that would be this line here. Okay, so what should happen is the center point of this end of the slotted hole should actually fall right on this line somewhere, and it should fall the same distance away that this one falls. So in other words, if I was able to actually put this between the two exact points, I could actually figure it out, or I could roughly figure it out. So roughly right there should be the other end of the slot. So if I just for giggles here, I'm going to rotate this so that this imaginary line right here lines up with, well, let me set this, yeah, I've got this set to 90 right now. So I'm going to rotate this so that this imaginary line, or this line I just lightly scribed, lines up pretty much with the 90. 0 degrees, boom. You'll notice that if there was a line running from the center line through my punch mark, it would line up perfectly. So this ought to work. Now I've got these blocks under here because I don't want this sitting flat on the table, because these slots have to be completely through, and I don't want to hit the top of my rotary table and damage it. So the next thing I need to do is I need to clamp this thing, but I've got to clamp it. I got to be smart about clamping it. I don't want to have the clamps in a place where they're going to interfere. So for example, I wouldn't want to put a clamp here, obviously, because this is where I'm going to start my slot. All right, I took some time to think about how I wanted my clamps, and also to figure out what combination of clamps are going to work. I have a limited amount of T-nuts that will fit this these slots here. I should probably make some more T-nuts when I get a chance. I also seem to never have enough hold downs of the right size. These two big ones here came out of the set that I have for the mill, which is not complete. I have another set that's incomplete, but it has big ones like this on it, which aren't going to really work on this. I got some of these small ones here, so I was able to get 3 clamps on there, and hopefully that's going to be enough. I might have to just take some light cuts, maybe baby it, because nothing will spoil my work faster than if this thing shifts on me. Now the good thing is it can't shift completely out of position because my locating pin's going to hold it there, but it could turn, and I guess worst case scenario is that would actually create, my slot would be a little bit longer than it should be, which I could actually live with that even. So the other thing I noticed about this table last time I used it for a job, I discovered that when using these T-slots to clamp a workpiece down to the rotary table, if I over tighten the clamps, the table gets hard to turn. It actually binds. It's actually binding. This is actually a little harder to turn than it normally is, and I don't understand why that is. My theory is that what actually is happening is that when I clamp this down to the table, that I'm actually distorting the top surface here, and that in some way is causing it to not work properly. So I'm you know, it's kind of a catch-22 there. I want this really good and tight so it doesn't move on me, but at the same time I don't want this thing binding up. And I just jammed a sliver underneath my fingernail. Ow. All right, anyways, I went to put my hand down here and there was a sliver on the edge of the workbench. Man, no wonder why bamboo shoots under the fingernails was such an effective torture. All right, so I think I'm ready to put this on the mill.